All right, so we're going to go over 1.10 Desmos, right? And this is also in your notebook. So up here, it talked about like, hey, I'm going to give you some information. You're supposed to give me more information. I will tell you right now, when you're doing this, there's levels to this understanding, meaning don't expect yourself to understand how to do everything all at once. No one ever does that. Like, think about how well you speak now, right? How well you speak now. Like if you ask your parents how you started speaking when you were younger, it didn't sound like that, right? There were words that sounded funny. Like when I was really little, I couldn't even say my R's. My brother's name is Rodney, so I'd be like, hey Rodney, let's go. But now listen to me, I can say my R's very clearly, right? So there's levels to this understanding. So I would call like these two right here, table and graph, is kind of like level 1. So level 1 meaning like everybody should be able to do this at the very, very least, right? At the very least. So a table and a graph. So it says here, it says, I know that the first 5 terms of the sequence are 0, -6, -12, -18, -24. What do you know? So here I already created my table. So my table goes like this: 1, 2, 3, 4, 5. And those of you who know and have been listening to Mrs. Johnson, you know that one of my favorite things is a table, because I get so much information from it and I can build other things like what, Miss Johnson? Like my graph. Okay, so here's the graph. It says 1, 0. So I make a little dot at 1, 0, boop. It says 2, -6. So 2, -6, 3, -12, boop. And then I can't even fit the other guy there. We've very slightly talked about why we're not going to connect these dots. We'll talk more about that in the next unit. But right now, just know, Ms. Johnson, the reason why we're not connecting these is because there's no 1.5 term, no 1.5 right term. Like, hey guys, what's the 1.5 term? That doesn't even make sense, right? So this is the first term, the second term, the third term, the fourth term. There is no 4th and a 5th term, right? It's just first, second, third. So we don't connect these. Their name is called discrete. Discrete meaning they're not connected, okay? Okay, the next part. So this is level 1. Now these two here, these next 3, like any parts of them would be considered your level 2 and level 3 understanding. Now, if you're trying to get all the way, like I really understand how to do this, you should be able to do these two here really well. And that's actually what I'm looking for tomorrow on, I mean, not tomorrow, on our test. Okay, so I'm going to work on finding a recursive and explicit equation using a constant ratio or difference. And then whatever else that they want me to find. Okay, type of sequence. Let's do that right now. What type of sequence is this right here? In the chat, if you can tell me, what type of sequence is this? Yep. Someone said, hey, Ms. Johnson, it's arithmetic. Exactly. So if you don't know this is arithmetic, what would you tell people? If someone says, hey, Ms. Johnson, why did everybody put arithmetic right now? Why would they do? Oh, and someone already put that. Hey, can you guys stop really quick? Be comfortable in putting it into the public chat. Okay. A bunch of you just told me, Ms. Johnson, arithmetic, 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 arithmetic. But why? Why is it arithmetic? Very good. So I'm gonna take this person's thing here. And I'm gonna, if this person right here shows me, I understand what I'm talking about, Ms. Johnson. I know this is arithmetic because there's a pattern and it's being added. Ms. Johnson, I know this is arithmetic. I know this is arithmetic. Sorry, I'm trying to write it. Arithmetic. And some people say arithmetic, but for some reason, and I can't explain why, don't ask me, okay? Or maybe you can, I don't care. But if you read this word, it's arithmetic, but when you say it's a sequence, they say arithmetic. I don't know why, but it's kind of like the read and the read. Like I read my book today. I read books every day kind of thing. It's kind of like that thing. I don't really know. That's why they say English is so difficult to learn. Okay, so this is arithmetic. Miss Johnson, why is it arithmetic? This person says it perfect. There's a pattern and it's being added. So whenever you're adding, it's arithmetic. Do you hear the alliteration? Arithmetic adding. Very good. Okay. So what else did they say that they wanted to know? They said explicit, recursive, constant, ratio, constant, difference. Type of sequence, we did that. There aren't any missing terms, so we don't need to do that. What would you try to find next? What would you try to find next? What would you try to find next? Oh, could you guys do the thing where you put it out to the public, please? Because I need especially our new students to see that this is something that's important, and if you don't participate this way, this is why it's going to hurt you. Okay, so yeah, exactly. We're going to find the constant or common difference. We're going to find the constant or common difference. Okay. What does that mean, Miss Johnson? Well, all it's saying is if I go back here to my table, it's the number that you add or subtract to get to the next number. So here, I'm going to clip this because I want to grab this right here. Let's snip this, copy this. All right, so here, I'm going to put my table. And this table is going to help me. Well, number one, they told me to write the table, but this table is going to help me find my constant difference. So, nice. Look at you, you fancy pants. Okay. Sorry, someone just explained to me why that works. Okay. So the next thing I want to do is I want to find my common or constant difference. Now here, what I do, if you've been watching Miss Johnson at all, she goes like this all the time, right? And she says, hey, you're going to subtract 6 every single time. Now, because this number is the same, that's what this person was talking about over here, that you have a pattern and it's being added or subtracted every single time. Why can't I see you over here? Oh, are you not working? Really? Oh, there it goes. Okay. So here's my constant difference. That's the number I added over and over again. But some of you are like, hey, Ms. Johnson, it's subtracting 6. Yes. Yes. Adding a -6 is the same as subtracting 6. Okay. So the big deal here is we're not multiplying. So I'm going to label him as my constant difference. What's another name that we would give him besides constant difference? What's another name that we give him besides constant difference? Yeah, slope. Exactly. So another name that we give him is the word slope. So for those of you who are participating and you're getting a bunch of answers in here, for those of you who are not, it is so okay to repeat people. If we were legit in face-to-face class, I'd say, okay, what is this? Okay, now turn and tell your neighbor. Tell them what they just said, and you would have to say it. Now, the reason why I do that is because the more you say it, the more you repeat it, the more you are getting it into your brain. Even if you are just repeating, okay? That's how I don't know, that's how you were taught how to speak, right? I would tell my kids all the time, like, hey, okay, now say thank you. Thank you, mommy. See, same. So constant difference, another name for him is slope. And the letter we like to use for slope is M. Miss Johnson, this is all coming back. Are we going to use that equation? Anybody know what I'm talking about? Are we going to use that equation? What equation am I speaking of?
Recursive?
Well, we are going to find the recursive, but what equation am I talking about? The moment that I said the letter M. Exactly. People have it in the chat. Very good. So yes, I'm going to use y equals mx plus b. Okay, so here I go over here, y equals plus b, and I'm going to use that color mx plus b. M. Oh, hey, Ms. Johnson, do you want me to put that -6 right there? That's exactly what I want you to do. So you want me to take the -6 and put it right there? Yes. Okay, he's the same guy. Remember, we call him the star of the show? Yeah, he's the star of the show. Okay. Okay, so there's -6. How do I find the rest of this equation? Anybody know how I'm going to find the rest of this equation? Yeah, what am I going to do? How do I do this? How do I find the rest of my equation? Yes, I have to find my y-intercept. Where's my y-intercept? So, okay, so I can just tell you right now, my y-intercept is not labeled, right? Exactly. So when I try to find my y-intercept, I go like this and I say, hey, I'm looking for this guy's y-intercept. So the definition of y-intercept that Ms. Johnson has told you is when x equals 0. When x equals 0. Now, shoot, I don't have 0. But if you did, it would go right there, right? All right, so squeeze them in there. Okay, if x is 0, what would my y have been? If x, did I say that right? If x is 0, what would my y have been? I think I said that right. Sorry, I'm trying to catch up with all the stuff in the chat. Okay, don't get nervous. Just get in there and just start answering questions. Very good. So someone said, hey, Ms. Johnson, you have to reverse the process. You do the opposite. So instead of subtracting 6 to get it, in order to go up, you would do the opposite. You would inverse it. So it would add 6, right? Or for those of you who are sticklers, no, Ms. Johnson, I must subtract 6. Good. Then the equation in your brain should say something like this. What minus 6 gives me 0? What, this number right here, minus 6 would give me my 0. And someone says, oh, Ms. Johnson, it's just 6. Okay. So that 6 there is your y-intercept. So I'm going to go y-intercept. So that's 6. So right there, I write 6. So here is my y-intercept. And because that's my y-intercept, there's my b. So then I'm just going to pull down my y and my x because there's my equation. In order for you to build an arithmetic equation, there's 2 ingredients that you need. You know how have you ever watched YouTube and they're like, I can make a cake with 2 ingredients, right? And those 2 ingredients are, well, I can build you an equation, okay? And the 2 ingredients I need are my slope and my y-intercept. Okay, my slope and my y-intercept. Okay, so this is done, Ms. Johnson. Yup, it's done. So this is my explicit. Okay, if you're having a hard time knowing who is who, if you're having a hard time knowing who's explicit and who's recursive, explicit is the one that can stand on its own. Explicit. Let me tell you something explicitly. Like, you don't need to know any other information except for what I just told you. So explicit, done. Constant ratio, done. We don't have any missing terms, no. And the last one is recursive equation. You're so funny, right? So here, recursive equation. Okay, so now I need to find my recursive equation. Yeah, so let me go, let me put them on top just because I have more room up here. So my recursive equation goes like this. Ready? So it's easier to figure out your recursive equation when you look at this stuff. So there's 2 parts to your recursive equation. Some of you already gave me the second part. Let me clip this. This is the second part of your equation. A bunch of people just gave it to me. I'm just choosing someone's. This is the second part. Well, there's one part that I'm missing, right? f of n is equal to f of n minus 1 minus 6. What's the other part that I'm missing? Yeah, I'm missing the first term. I'm missing the first term. So f of 1 equals to what? 0. So f of 1 equals 0. Done. Okay, so here's your recursive, here's your explicit. Now, like, let's like make fun of this really quick. Which part of this do you not like? Which part of this do you not like? Then that's the part that you need to pay attention to. Okay, whichever part you don't like writing a table, do the table first. You don't like finding the constant difference, make sure you walk very carefully around this part right here. You don't like finding y-intercept, maybe that's the first thing that you should find. Whatever the case might be, there's like, in my like understanding, there's very little here that is technically new for you. Okay, the new thing actually is right here, recursive equations. You've never seen recursive equations before. Okay, here you've seen y equals mx plus b before. You guys have been graphing it since 7th and 8th grade, I want to say, right? And sometimes even 6th grade, depending on like how your teacher taught you, right? You've been able to find patterns since literally you were in 2nd grade. Arithmetic may be a new term to you, but what here is the difficult part? Which part here is difficult? Any difficult part? Okay, so this is an arithmetic sequence. I'm going to go over this geometric sequence, and then I'm going to have you guys pause and then just do it. And there's technically no order. Okay, someone said I just don't like the order. Technically, you could find this first. You guys all know Miss Johnson. You know what she's going to choose to do first every single time. The table, Miss Johnson. Every single time Miss Johnson's going to draw the table every single time. And it just makes sense to me. And that's why I do it every single time first. Okay. The rest of this is up in the air. Like, you know, for example, like, like, what do you do first in the morning? Do you brush your teeth? Do you make your bed? Do you, set out your clothes? Like, which one of those things do you do first? Now, some of you, like in your brain, you have to do certain things in that order. Like, I like to brush my teeth before I get my clothes on, because then I don't, you know, splash toothpaste all over myself, which has happened before, kind of thing. But none of those things that I said, brush my teeth, brush my teeth, make my bed, or get my clothes ready, none of those things have to go in a particular order. None of these things have to go in a particular order. The constant ratio or the constant difference, I'm pretty sure, I mean, because you know how to find the explicit and recursive, most likely this will come before those two things, but everything else is kind of like your choice, kind of like a choose your own adventure. Which way do you want to do it? Okay, moving on. Okay, for this one right here, this next one. Okay, it says, I know that it is a sequence where f of 1 equals 5, and the constant ratio between the terms is 3. What do you know? Okay, so you tell me, what would you do first? Of these things here, I'll have this list here. Looking at this, and I know this is super tiny, you know, f of 1 is 5 and the constant ratio is 3. What would you all do first? Table. I know, I've influenced you so much, right? Okay, fine, let's do the table, because I really like the table too. Like, that's a good influence, right? Like Miss Johnson. Oops, sorry. Let's grab this table. So I'm gonna copy this table, and I'm probably gonna copy it again and again. So I'm gonna put it here, and because Miss Johnson likes her tables, I'm gonna just do an extra one while I'm not. Okay, so here's my table for this number 2. Okay, so what would yeah, me too. I would exactly do that. Okay, so this is what someone says. Hey, Miss Johnson, the very first thing that I do is I'd find the table and the next term. And then this person describes it. She says, because it's kind of like a list. And that's exactly where my brain goes. This is a very sequential like type of thought, right? And I'm going to put this over here because I want to, because you know it's going to come over here. If you know about me and this table, you'll understand why I'm going to do it like that. Okay. So how do I fill out this table? What will I do? What should I do first, guys? Yes, very good. So this says, Miss Johnson, f of 1 is 5. So that means over here for x, I don't know, you guys want to use x this time? So x and f of x, 1 is 5. Okay, now what? What does it mean that the constant ratio between the terms is 3? What does this tell you? The constant ratio is 3. What does that mean? Yeah. Okay. So this is what someone said. It means that we multiply by 3, and then someone else said it actually means it's geometric. Very good. Okay. So I gotta get some other, man, I wish I could. Okay. I'm going to just do it one by one. Be patient, Miss Johnson. So someone said ratio means geometric. So I need to put that in there. I'm just going to put your little notes over here so that we can get this. Someone else said, it means it's geometric because we're multiplying by 3. So both of these things are really strong pieces of information. And if you didn't know that, guess what? Now you know it. So there you go. Okay. So here, ratio means geometric. It's geometric sequence. So that means we're multiplying by, if this says 3, don't worry about that. Okay. So then, keeping my participation. So then how do I find my next term? Just multiply by 3? Oh, okay. So go like this, times 3. So that's 15. So I'm just going to go like this the whole time. If you know, Miss Johnson doesn't like writing her table like this for geometric. Do you guys all know how I like writing my table? So I'm going to put these numbers in. Actually, I'm not even going to multiply, right? Do you guys know? I'm not going to multiply right here. What am I going to write right here? Yes, exactly. Miss Johnson likes writing these, and she likes spreading it out. So she's not going to, I know what 5 times 3 is. I know that. But actually what I'm going to do is I'm going to leave that 5 there, and I'm going to say times 3. And then next one, I'm going to put a 5, and then I'm going to go times 3 times 3. Ms. Johnson, don't you know your multiples? Yes, I do, but I don't care about it. Right? So every single time I'm doing that. And so I'm going to get rid of this times 3 because this guy's called my common ratio. I'm going to erase that because I know what that is. I'm going to write it up here. Here's my common. Ms. Johnson, how come it's called a common ratio or a constant ratio? It just depends on the language that like how your teacher said it. So I go between both of them so that you all are prepared for whatever comes at you. So constant ratio and common ratio are the same thing. So this is like a $10 bill and this is 2 $5 bills, right? Okay, so then I'm gonna continue counting on 2, 3, 4, and I'm gonna write X down here. Okay, I already figured out that it's geometric, right? Let's look at our little list. I figured out that it was geometric. I found they gave me my constant ratio. I made a table. I haven't made the graph yet. I'm okay with that. And then now I'm just on explicit and recursive. So which one irritates you more? Do that one first, not last, first, because then you won't be tired of it. Okay. So which one do you want to go with? Recursive or explicit? Okay. Oh, someone said the explicit would be 5 to the 3n minus 1. I don't know. Let's see. Let me click that. Someone said this. I like putting it. I like doing this because then you guys are like, I wonder if she's talking to herself. I'm not talking to myself. Okay, it would actually go right here. 5 times 3 to the n minus 1. Oh, I see that 5. It's that 5. Okay, let's put this down. This 5 is that 5. Yes, exactly. That 3 are those 3s. And then because this person gets how to look at the patterns, if there's 4 of them, there's 3. If it's of 4, then it's 3 of them. That means it's just minus 1. So it's n minus 1. Very good. Done. Explicit is done. There's my explicit. What about recursive? What would recursive be? No, you're good. Don't worry about that. Ooh, recursive. Someone put this as recursive. I don't know. Let's see. Can you guys look at this and say if you agree? Can you look at this and see if you agree that this is recursive? Can you guys see if you agree if this is recursive? So if I want to read this in English, for those of you who haven't read, aren't fluent in reading this as math, this just says the next term is equal to the previous term times 3. So the next term, this guy here, is equal to the previous term, times 3. And then there's your first term, f of 1 equals to 5. I'm just going to put a little semicolon in there, just so that people know that these are two distinct kind of like sentences, if that makes sense. Very good. Okay, if for those of you who forgot the first term, like this is something that I saw over and over again on your last quiz. A lot of you forgot to put your first term. So if that's what you forget, that should be the first thing that you should do. So I don't know how many times I've gone to the grocery store and I don't have my list on me and I'm like, I'm just coming in for eggs. And then I get in my car. What did I forget to get? The eggs. So what I do is first of all, I always have my list because it's on my phone. Second is the very most important thing I do is I get the thing in my cart first. Does that make sense? So whatever you forget, put that in the very front. Okay. Hopefully this makes sense. I'm going to stop recording.